right, thank you. So today I'm so excited to be here. Like she was mentioning, like Claudia was mentioning. Did I get your name correct? Thank you, Claudia. Yeah, I work at Solo. I've been one of the founding member in the Istio community. I worked at IBM for 5 years on Istio before I joined Solo. So been Solo for almost 2 years. Really excited to be here. And I actually saw some of my team members very nicely to be here to support me. So thank you for that. So today we're going to talk about future of Istio, which is without sidecarless, and with Istio ambient service mesh. So let me go to slideshow mode. Let's see. All right. So Istio, as you all know, is the industry's leading service mesh. Right? Istio being around since 2017, so it's almost 6 years now since we first launched Istio at GlueCon. And the most two major milestone for now is Istio is launched the ambient service mesh, which defines the future of Istio in September. And Istio is also part of a CNCF project now as an incubation project. So those are the most two major milestones of the Istio project. Ambient Service Mesh was launched by the Istio community with large contribution from Solo and Google, I believe on September 7th, right after the Labor Day holiday in the United States. So what exactly is Istio Ambient Service Mesh? Is the new data plane mode that's being introduced to enable you as a service mesh user to run Istio without sidecar. And when we design Ambient, it's really going after the three key functionalities we're trying to simplify and optimize for you. Yeah.
Sorry, Lynn, I'm gonna interrupt you because the presentation is loading, and so I don't know if you can reload your.
Okay, let me figure that out. Thank you for interrupting me. That's well needed.
Thank you.
So what I'm going to do is I'm going to stop sharing and resharing. See if it works better.
Okay, sounds good.
All right. And if it doesn't work, I'll try to share my entire machine. Okay. Well, I'm excited about the energy of you all. I keep hearing all the beeps. So thank you all for joining. Really appreciate it.
There you go.
All right. I think the problem is when I go to full screen. Is that when you see the problem? So what I'm going to do is I'm going to go to full screen and you let me know if there's a problem. Actually, let me change to presenter view. That may work better. Oh. Now, can you see it?
Yes, I can see it now. Good.
All right, great. Well, what I was just mentioning probably is okay without slides. So I'll just start right here. So we designed Istio Ambient Service Mesh for three key functionalities to improve your experience of service mesh. First of all, we want to simplify the operation. So you all know as you add your application to Istio today, you have to kind of drag that sidecar components, right? So it's not as transparent as you would like to. For instance, the sidecar may have a lifecycle issue with your application where it's starting at interesting timing that would cause issues for your application. For instance, maybe you support Kubernetes jobs, which we don't really nicely support in Istio with the sidecar model, and you have to work around that. We know it's really painful. So Ambient is designed to simplify operation for you so that you don't have to make any changes to your application. The second major benefits with Ambient when we design this is cost reduction. What does that mean? So when you deploy your sidecar today, you don't get to choose how many replicas you want to run your sidecar. The reason is how many replicas you are running your application, you automatically get the same replica number for your sidecar, right? Because it's running alongside of your application. So it scales concurrently with your application. And a lot of times you may not need that many sidecars, but you lose that control. And the other thing with the sidecar approach is, even though you just adopt maybe just one feature of Istio, for example, mutual TLS, you still have to pay the entire cost of the sidecar that the Envoy sidecar actually can handle layer 7 processing, including telemetry, routing, even though you're not even leveraging any of that feature. Improved performance is another thing it's a goal of the Ambient Service Mesh. When we initially launched Ambient in September, I have to be quite honest with you all, we didn't really reach much on the goal of improved performance. It's probably about the same performance as the sidecar, but the community still continue involved in this area, and we've seen some really, really promising data that it's actually a lot better with Ambient than the sidecar. So we will share those data when we are ready to share. So what exactly is Ambient Service Mesh? Essentially, Ambient Service Mesh moved the sidecar proxy architecture to a per node architecture so that you can run proxy per node. And most importantly, Ambient make it transparent to your application. So you don't have to restart your application. You don't have to make any changes to your application. So from a business perspective, we talk about all the benefits of the Istio brings to business owner, platform team, and application team. And my favorite really is the transparency that we brought to your application through Ambient Service Mesh. With Ambient, you can leverage the secure tunnel, which is the Z tunnel, independently from the layer 7 processing. So the way it works is there is a co-located Z tunnel component, which we also call it secure overlay layer, that provides secure overlay layer to make sure to upgrade your connection to mutual TLS to be able to terminate the secure connection from the sender to be able to handle zero trust from mutual TLS to even simple RBAC rules from Istio. So that's what Istio Ambient Service Mesh provides through the Z tunnel, which is the layer 4 proxy on this diagram. The layer 7 proxy, which is implemented using Envoy, is it's an optional component, right? You only pay for that component by actually needing to have layer 7 processing, or if you need layer 7 telemetry, or if you need the routing components, that's layer 7, that's when you decide you want layer 7 proxy for your application. So you don't necessarily need it, and you don't need to pay for it all the time, which is really, really nice. So this 2-layer architecture is one of the key thing, innovation we introduced with Ambient. All right, so Istio Ambient doesn't mean Sidecar is gone, right? We will continue to support Sidecar because we understand many of you are using Sidecar today, right? Many of you are probably comfortable with Sidecar, or maybe comfortable with Sidecar with some of your applications. So we expect Sidecar will have a place, and they will continue to exist. And particularly Sidecar will be there as you looking into migrate your traffic from Sidecar to Ambient. If one day, Ambient reaches production ready next year, and you actually think Ambient may be more secure than the sidecar, or maybe more cost effectively than the sidecar, or maybe you just love Ambient because it's the transparent that you don't have to make any changes to your application. So what's really nice about the Ambient Mesh is not only we enable the new Sidecarless, we also enable the interop between the sidecar to the Sidecarless. In fact, Istio 1.16 was just announced this Tuesday, and Daniel on the call is the release manager, the lead release manager from Solo in the community. And in that release, we actually enable the sidecar to be able to speak the Edgebone, which is the HTTP overlay tunnel that ztunnel understand, so that sidecar can interrupt with ztunnel, with Waypoint proxy, with any of your application in Ambient Service Mesh. If just in case if you're wondering, why Solo is interested in Istio, or why Solo is interested in Ambient Service Mesh. So at Solo, we have a product offering called Glue Mesh, which provides abstraction on top of Istio, so that as you adopt Istio Service Mesh, we want to simplify that experience for you and provide integration from the API gateway to the mesh to the underlying CLI for you. So just so you understand why we are a key player in the Istio community. Now let's go back to talk about the ztunnel architecture. So the C here is the client and S here is the server. So essentially, when the client, for example, client 1 sends a traffic request to server 1, the client 1, the moment it's trying to send the request, the request is going to be captured by the ztunnel co-located on the same node. And then the ztunnel will check the identity of this C1, client 1, and ztunnel will check if this client 1 already have the key certificates, because ztunnel has the capability to do certificate signing requests on behalf of all the pods in Ambient on that particular node. So ztunnel will go ahead and upgrade the connection, which is you saw in green here, through this secure overlay that we talk about, which we call it Edgebone. And then it will, by the way, it will try to reuse the Edgebone tunnel if there's already a tunnel exists between C1 to S1. If there's nothing existing, we'll go ahead, create the tunnel, and then send the request through that secure overlay tunnel. And then on the receiver side, which is the destination ztunnel, so when the traffic gets to the destination ztunnel, the first thing it does is to terminate the connection, so it can kind of send decrypt that traffic and then send the decrypted traffic with plain text to the original destination here, which is S1 here. So in this diagram, you also see ztunnel is communicating with Istio D. So ztunnel essentially serves as a XDS client, right? It talks to Istio D through XDS protocol. It receives the XDS configuration from Istio D, so it actually knows, which destination it needs to forward the traffic to, and whether the destination have support for Edgebone, right? Be able to understand Edgebone traffic, because if the destination doesn't support Edgebone, it would send plain text, right? So that the destination can understand the traffic. ztunnel is also served as a CA client. So ztunnel has the ability to impersonate on behalf of each of the client to be able to send the certificate signing request to the Istio control plane, and then the Istio control plane double checks, okay, you are the ztunnel for this particular client. Are you allowed to represent this particular client? If you are, let's go ahead, give you the signed certificate. So that's how it works at a high level of the Z-tunnel components. Now, this is another visualization of the Z-tunnel component. It particularly highlights how the traffic redirection from application A to Z-tunnel works. So it's implemented through the Istio CNI. In fact, Daniel on the call actually did a lot of work on that. So I want to give a shout out to him. So essentially, we set up the traffic routes. We set up the IP tables to enable, by routes, I don't mean the Istio traffic routes, I mean the routes and IP tables that's set up by the Istio CNI to make sure the Z-tunnel can capture all the inbound and outbound requests. So it always goes to the co-located Z-tunnel on the same node. So that's number one, important in this diagram. Number two, important in this diagram is the identity. So we try to help you highlight how to understand the identity through the mutual TLS request, right? So the Z-tunnel in this case is trying to impersonate service A. So it will have the key and search from the application A. It will also have like the SPIFFE ID, the SAN for the application A. The application D in this case is the destination, right? So the destination Z-tunnel on the right side will be able to impersonate application D. So it will have application D's keys and certs and the SPIFFE ID. The Waypoint proxy, which in this case, it does deploy a Waypoint proxy, which we mentioned it's optional for application D. So Waypoint proxy is using the identity of the application D. So it actually has application D's key and certs and also signed from Istio control plane. So Edgebone protocol is the Edgebone overlay is established between the Z-tunnels and also the Z-tunnels to the Waypoint proxy and also from the Waypoint proxy to the Z-tunnel. So it runs on a dedicated port 15008 between the proxy in the data plane and then uses mutual TLS and strong identities very similar to how Sidecar works. The only difference is though the Edgebone is hidden to your workloads. It's not used by your application. So this enables us to provide a better transport protocol to your applications, so that we do expect Edgebone would allow us to support server-side first protocols, for example, MySQL, to enable us to better incremental adapt Istio, particularly maybe when you bring your own TLS certificate. And also support calling pod IP directly so that you can eliminate ways around Istio, doing mutual TLS and encapsulation that we see today. So so that's how, on a nutshell, of Edgebone. With that, I know you guys are all here for the demo, so we're going to jump into the demo. Is there any questions before we get to the demo?
Yes, I think there are quite a few questions here. So here we go. First one is from, give me a second.
Yeah, I just admitted
source
her.
nodes become very difficult for users to understand and specify why Istio proxy injected and the additional resources it adds. That's like, I'm not sure if it's a question, but there's also a question from Yields. The fact that traffic is not encrypted between externals isn't a security regression. That's one. And then relevant to Jail's question, the Istio CNI would have redirected the traffic to external through web tables, but that means the tunnel runs in many different network namespaces at the same time. Traffic will exist networks in S, and then I think there's also another question in the Q&A session. In this new approach, how the single point of failure is addressed. It is embeds in the node, aka as a process in the node. What are any limitations to use eBPF instead in tables for Istio? And well, maybe you want to start with those, and then we jump to another ones.
Okay. I just realized there is a question and answer tab too. I was looking at the chats. So let me answer some question on the chats first. I think, Brian, you had a comment about resource code has become very difficult for Kubernetes users to understand. I totally agree with that. This is one of the challenging with the proxy not being transparent, and also it's very hard to get the resource quota correctly, and it requires a lot of testing, and also not only testing your application but also testing the other application co-deployed in your Kubernetes cluster. This is exactly why we thought of separating the two-layer approach, so that allow you to easily budget for the resources for Zeta node and the resources for the Waypoint proxy, and also break it out so it can scale independently out from your application. A presentation, yes, we will definitely share with that. Okay, so there's a great question about traffic is not encrypted between Zeta node. Is that a security concern? That's a great question. So the way I want to encourage you to look at security in this case, right? This C1 to Zeta node, you're right, it's not encrypted at the moment. In fact, we don't have plan to encrypt it in the short term when Ambient goes live in Istio master branch. The main reason is I want to encourage you to think about this as the sidecar. So if you look at the sidecar today, right, the C1 to envision for a moment Zeta node is your sidecar. The communication between C1 to your sidecar is also plain text, right? So if you are a hacker that gets into the node and be able to sniff the traffic, which typically requires, I think, a sysadmin or net admin type of privilege, you could sniff this traffic C1 to Zeta node similarly as how you sniff the C1 to C1 sidecar. So from a vulnerability and attack surface perspective, it's actually pretty similar. In fact, I could even mention to you a bunch of things in this architecture is actually way more secure than the sidecar approach, which actually will publish your blog on this if you go to istio.io. But one thing I really want to highlight for folks is imagine your Zeta node. When Zeta node is compromised, it's very similar to each sidecar on this particular node, which is C1 and C2 sidecar compromise. And the fact if you can compromise a Zeta node on that particular node, you will absolutely be able to compromise the sidecar on that node. However, if you know how to compromise the C1 sidecar on that node, you don't actually know how to compromise the Zeta node on that node 2/3 of the time. The reason is only 1/3 of the Envoy CVE comes from layer 4 processing, which is what Zeta node is. So from that perspective, Zeta node is actually more secure. Yeah.
Okay, I think there's a question from Ulrich, right?
Sorry, I need to jump in here in live. I don't agree with that statement, because today the communication between the proxy sidecar and the process is on localhost only, which makes it more secure. The attack surface with the ctunnel is at least a magnitude higher. So I would really question that. Also, as you said, if you can hack into one sidecar, you can hack into all. I wouldn't subscribe to that statement. If you can hack into the node, you can compromise pretty much everything on that node, including the pods. But you also have to hack into those. I mean, essentially, yeah, you're right. I mean, there is some similarities, but I think the attack surfaces with the cTunnel is higher, is bigger than if you use the sidecar from a security perspective. So I think you should really rethink that and look closer at it.
I think maybe we should follow up this offline. So one way I want you to follow up is we do run every Wednesday, we run Ambient workgroup meeting, except the next Wednesday because of Thanksgiving. So 1 p.m. Eastern, we would love to have you join there. Because there are other perspectives that we should also look into. I agree with you. If you are just looking at one sidecar, maybe you would think that zTunnel has a much bigger attack surface, but zTunnel is managing many sidecars. But I'm sorry, many applications on that node. Yeah.
I'm not disputing your claim that it can be more secure. I just don't think, as it is presented today, it's more secure. Just wanted to bring that up. This is a bit too much marketing message here. Please stay open, stay honest and true.
No, I'm not doing marketing because I'm not selling anything. I want to be clear though. One thing about zTunnel is the reduced attack surface. I want to make sure everybody understand, right? If you look at 100 Envoy CVE, only 33 are coming from layer 4 processing. So if you know how to hack into your proxy, because one of the CVEs and 2/3 of the chance you won't be able to hack into your zTunnel, but 100% of the chance you could potentially hack into your sidecar. So that's like very important stats to be made aware of. And obviously, I know there are some users have some concerns. In fact, if you look at Cilium CNI, I believe in some of the older version of Cilium support, there is a way to potentially to encrypt this traffic. So that may be satisfied for user like you who really are concerned with this, but it's not the top priority for the Istio community at the moment. All right, I think we have a lot of questions. Claudia, should I go through the demo and come back to the question?
Yeah, I think so.
Yeah,
because
I think I could spend the remaining of the time answer questions too, but some of you may love to see the demo.
Yeah, sure.
All right. All right. So I do have an environment up running. So I hope the demo gods are with me today. So to save us time, I believe I already have the Ambient profile installed. Sorry, I can't type today. Let me fix that. So in my environment, I have the Ambient profile installed. I have a Kubernetes cluster. Actually, just explain my environment here. So I have a Kubernetes cluster with 4 nodes. On each of the nodes, you are going to see the zTunnel installed, which is what you see here. And also on each of the nodes, we have the Istio CNI also installed here. As far as the application, I have the famous sleep application. I also have an application which is same as sleep, but the only thing is the identity is different. So we call it not sleep. We also have the web API recommendation, purchase history application, which are dummy services derived from Nick Jackson's fake services, if you're familiar with that. So we have all these applications deployed in the default namespace. Notice there's no sidecar here, right? It's all 1/1. Okay, so the first thing we're going to do is we're going to do a namespace to indicate I want to include the default namespace to be part of Ambient, right? So it's just as simple as label it. Now, the moment you label the namespace to Ambient, and if you happen to check the Istio CNI logs, you are actually seeing the Istio CNI doing work, right? To be able to figure out what are the right redirect configuration for the IP table and routes, right? So that's what we were talking about. The Istio CNI constantly monitors the paths to see which ones are in Ambient, and take action correspondingly. So this is what Daniel helped us to implement in upstream. So we did that, and then the next thing we're going to do is we're going to go to, in fact, right now, all our paths that we looked at in the default namespace are part of Ambient now. It's actually really, really simple, and I didn't have to, reboot anything. You can see this was still 29 minutes earlier, which is before this call, I deployed the application. So the next thing we're going to do is we're going to generate some traffic, right? So from the sleep pod, we're going to send 100 requests, I think, to the Web API service, right? So so you're going to see a bunch of 200, right? So this actually goes through, ideally it would go through the Z tunnel on the source and destination Z tunnel, and then have the connection upgraded using mutual TLS through the Edgebone tunnel we talk about. So let's take a look at a Z tunnel log. So in the Z tunnel log, you will see traffic about the HTTP connect, for instance, like this one. You can see how Z tunnel sending outbound traffic, and you can also see how Z tunnel process the inbound traffic. So for instance, these are all in the logs. So that's how the traffic, all after the CNI set up the redirect, the traffic always goes through the Z tunnel, and then the Z tunnel figure out what's the destination Z tunnel, and then forward the request to the destination Z tunnel. So the next thing we're going to do is apply a simple authorization policy. So this simple authorization policy essentially said, hey, look, we're not going to allow anything in the default namespace. So so now if we do a simple call to the default namespace, then I think I'm missing a gateway IP, just making sure. Okay. So yeah, so let me think out my gateway IP. So just a second. Okay, so I would expect my gateway IP to be, if it works, to be this external IP. So now, actually, maybe I had the gateway IP. Now that I'm thinking, yeah, because of the RBAC policy, the authorization policy I deployed, so we didn't allow that connection to go through. Yeah. Now, the next thing we're going to do is, you know how zero trust normally is allow D-line everything first, right? And then you gradually allow what's absolute minimum to allow it to access, right? So the next thing we're going to do is, so let's see, we did this allow nothing, and we were going to apply authorization policy to say, look, if it's, let me move this a little bit so you can see it better. Look, if it's from the Istio ingress gateway, or if it's from the sleep pod, yeah, sorry, this is a little bit hard to move, but I'll show you here. So if it's the Istio ingress gateway, or if it's the sleep principal, let's go ahead allow it to access the web API. And in the meanwhile, because Web API talks to the recommendation service, let's go ahead allow Web API to talk to recommendation service, and similarly allow recommendation to talk to purchase history. So let's go ahead apply this authorization policy. Now, hopefully, this would work now. Yeah, so it did. So before the IP is probably set correctly, but but it still works now. So now, if you try to remember, we had on not sleep, right? So if you try to access web API from not sleep, which is not on the authorization policy, you will get the package dropped because we know that's not allowed to access it. So that essentially, so what it shows you is how zTunnel works from source to target, and how you can leverage zTunnel to enforce simple authorization policies. All right, so with that, we're going to progress to the next demo, which is focused on Waypoint proxy. Right. Okay, so for this exercise, we're going to go through sending GET request, which is a layer 7 processing, right? It's not a simple layer 4 request because you have to interpret the request, whether it's GET or something else. And we're going to enable GET request from sleep to web API. And we're going to try some other requests, and it should fail. So we're going to define an authorization policy to enable the GET request, but GET request only. So, so in order for us to deploy a Waypoint proxy, the first thing we're going to do is we're going to use the Kubernetes Gateway API. And in that API, we're going to specify the annotation for the web API service account, because we want to deploy a web API Waypoint proxy, because the layer 7 processing is only for the web API here to check the GET request or non-GET request. And the way you deploy a Waypoint proxy is through the gateway class name called Istio mesh. All right, so that should deploy the Waypoint proxy for us. I believe Greg Hansen on the call actually helped implementing some of these as well. So it shows you the status is running. You can also describe the gateway to see status. Yep. So it shows you a little bit more status that it is a Waypoint. It's deployed by the Waypoint proxy controller, which is the Istio control plane at the moment. All right, so we got our Waypoint proxy running, and now we're going to deploy the authorization policy that we mentioned, right? So we're going to allow sleep and Istio ingress gateway, and it can only allow the GET operation and nothing else, right? So now if we go back to call from the sleep pod to web API, you know, the request still goes through, it calls web API, which calls purchase history, calls the recommendation, which calls the purchase history. So that is all good. Now, if we try to call it using the sleep method instead of the GET method, it actually gets access delined. So that access delines comes from the Waypoint proxy. So if you go to look at the Waypoint proxies log, you should be able to see that. So we do logs on the Waypoint proxy. Yeah, so we should be able to see the Waypoint proxy. I guess the log hasn't come in yet. Yeah, sometimes it takes a little while to come in. Yeah, but it is the web API's Waypoint proxy to deline this this long GET request. All right, so the next thing we're going to do is we're going to check out layer 7 observability features provided by the Waypoint proxy. So in order for us to do that, we're going to get into the Waypoint proxy and look at the stats, permissive stats, and check out one of our favorite stats called Istio request total. So as you can see, it shows, how many total requests we got for 200, how many total requests we got for 403, which is 1, so that is right. And the request total for 1, that is also right, because we only send 1 GET request. So if we send another GET request, if we send another delete request, so now if we go back, we should see this counter increase, because now we have 2 dimensions. So that's how layer 7 telemetry works, provided by the Waypoint proxy. The next thing we want to do is inject some resilience feature by injecting some arrow into the web API. So to do that, we're going to inject float, which should be very familiar with you all. And we're going to say, hey, if user is Amy, we're going to inject 100% time, inject this delay of 5 seconds. And if user is not Amy, it's going to go through to the web API directly. So let's go ahead, do that, deploy this virtual service. So now if we actually call Istio explain.io using Amy, now we're going to see 1, 2, 3, 4, 5, right? So that's the delay. It's being injected by Istio through that Waypoint proxy. Now, if you call it, maybe use a different user, or maybe not specify a user, you shouldn't see any delay, right? So that's how it's really nice to be able to inject delays into your environment. Continue use the same virtual service today. The next thing we're going to do is traffic shifting. So basically, we deploy a version 2 of our purchase history. And in order to do a traffic shifting on purchase history, we will also deploy a Waypoint proxy for purchase history. And then we're going to deploy this virtual service that says I want 90% traffic goes to version 1 and 10% of traffic goes to version 2 of my purchase history. And we're going to also deploy a simple destination rule for the purpose of specify the subsets for version 1 and version 2. All right, so with that in place, now let's send 100 requests to web API and then try to see how many of them are purchase history version 2. So we got 12, which is about 10%. So yeah, so that's how you can do traffic shifting. You can do layer 7 telemetry. You can do reach authorization policy through Waypoint proxy. Yep, so that is my demo. With that, I'm going to try to see if there's any questions we should take.